In this video, I'll talk about the voltmeters and ammeters. A voltmeter is an electronic device that measures the potential difference, and this potential difference could be across either a resistor, a capacitor, or inductor. The most important thing about the voltmeter is that it has to be always connected in parallel. Remember, it has to be always connected in parallel to the electrical component whose voltmeter we need to measure. It has to be always connected. And in general, a voltmeter that we generally denote by this way. So if we have to represent a voltmeter, this is the symbol of a voltmeter, V. That's how we denote it. And it is always connected in parallel. And it has almost infinite resistance. It has a huge resistance. Okay? It has a huge resistance. So a voltmeter is never connected in series. If you connect it in series combination, as this one has a huge resistance, the current into the circuit will almost be equal to 0. It behaves like just an open circuit if you connect it into if you connect voltmeter as a series into a circuit. The circuit will just behave as an open circuit. That's the reason you never connect the voltmeter into a series combination. It is always connected into parallel combination. Let me explain this one. So here I have a circuit here, and this is the voltmeter here. And now let's say I'm interested in measuring the potential across the 50 ohm. So how do you do that? You connect one terminal and put across 50 ohm. And then you take another component and measure across this way. You see 100 volt. Now let me break the circuit and try to connect into the series combination. Now if I want to measure the potential across here, it gives me 100 volt. Well, now what I'm going to do here, I'm going to connect into a series combination. Let's see what happens here. In order to do that, first I'm going to break the circuit here. Okay, so I broke the circuit here and connect one terminal here and to another terminal here. Okay, the circuit is in fact completed. So but there is no any current here because this one has a huge resistance. So there is no current flowing through this one because this voltmeter has infinite resistance. So there is no current flowing through this one. So the circuit just behaves as an open circuit. All right. So let me disconnect back here. Okay. So now the current starts flowing. So if I have to measure, I always will connect across it, or I have to connect it in parallel here. Let's say if I have to measure across 25 ohm, I'll just bring it across 25 ohm. Okay. So this is how we connect a voltmeter. Now let's go back here and talk about the ammeter. So in this picture, I have just denoted in differently here. So this is in fact a battery here. And there's a red here. We see a resistance here too. This resistance is in fact the resistance of the battery itself. Any battery you take in the wall has a small resistance that is called the internal resistance. Okay, so this is what it represents, the internal resistance. So this is the correct way of connecting. You have to measure across it. If you connect across this way, that's the wrong way. That means there will be no current. The current in this case will be approximately 0 because this one has infinite resistance. Okay, it won't damage the circuit here because this one has infinite resistance, so no current will be flowing through this one. So still the circuit will be the safe, electrical components will be safe, but no currents will be passing through this one. Now let's talk about the ammeter. Ammeter measures the current into any electrical component, and this is how we represent the ammeter here. So, and this is A. So this is the ammeter symbol here. It measures the current, and it has to be always connected in series combination, and the resistance of an ammeter is almost equal to 0. It does not have any resistance at all. So ideal ammeter has, or best ammeter has, no current into the circuit. So the resistance is 0 ohm. So now let's see how do you connect into the circuit. So here I have a circuit here, and if I want to measure the current at this point, this is how it has to be connected. If you want to measure in this path here, this is how it has to be connected. You will never connect this way ammeter. This will be wrong way. If you connect, let's say you want to measure across R1, then you do not connect this way. This will be wrong. Okay, so that's what it's showing here. You never connect an ammeter into series. It has to into a parallel combination. It has to be always connected in series combination. Okay, and two things you have to remember. This one, ammeter is always connected in series. Let me write down here. Ammeter always in series, and resistance value is 0. Voltmeter always connected in parallel, and its resistance value is infinity. So now, as resistance has 0 ohm, almost it has no resistance. So if you connect into a series combination, it will not change the current. And let's see, if the ammeter has some resistance, then these two will be in series combination, and then it will change the current. So ideally, any ammeter has to have a very tiny or 0 ohm resistance, and the reason is it should not change the current in the circuit. If it has any resistance, if an ammeter has any resistance, it will change the current into the circuit. So ideally, any ammeter has to have 0 ohm resistance. Similarly, voltmeter has to have infinity resistance, a large resistance, and the reason is because it is connected into parallel combination. As this one has a very high resistance, now let's see, the current is now splitting up, it is dividing up. As this one has infinite resistance, so insignificant or 0 current will be flowing through this one. So it measures the current into this or the potential difference across the resistors very accurately. Okay, if a voltmeter has some resistance, then there will be current flowing through this one. That means the potential measured across R will not be the true potential difference. So ideally, a voltmeter has to have infinite resistance so that there's no any current passing through the voltmeter itself. So let me talk about all these things through the simulation one more time. So here now I'll talk with both the ammeter and the voltmeter. I'll connect, let me break the circuit here. I'm going to connect one more resistors here. Now let's say you have to measure the current through 10 ohm. How do you connect it? So this is the ammeter, this is the current. So how do you connect it? So if you connect this way, let's say the way I'm doing right now, it's a wrong way. This is the wrong way. You see now immediately you see 7 ampere current is flowing through this one. It was a huge current, so it will blow up the circuit. So this is the wrong way of connecting. So how it has to be connected? So okay, so the way it has to be connected is, let me break this one. You connect them into a series combination. Now you see it's a 4.12 ampere. Okay, so this is the way it has to be connected. It always has to be connected in series combination. Okay, so now let's say you have to measure the current through 50 ohm resistance. Or let me do one more quick thing here. Let me delete this one. Let me delete this one too, just to convince you more. Okay, here let's say we have only three of them, and we want to measure the current through 50 ohm. So there are two possibilities. The one is I'm connecting 50 ohm this way, which is the wrong way. First I'm doing the wrong way, then we'll do the right way. You see now the current is 40, almost 453,000 ampere. No wire can in the world can withstand this amount of current. This is a simulation, so it won't blow up. You see now that there's a fire here too. It will blow up. It's going to blow up. It will damage your electrical components. So never ever connect a meter into parallel combination. And now if I measure, let's say I have another ammeter. If I measure here, almost no current will be passing through the 25 ohm. You see, compared to this current, there is insignificant amount of current here. So this one is 453,000, and here it's about 0.818. So insignificant amount of current is passing through this circuit here. Okay, so it might blow up your the battery or your electrical components. So never connect ammeter into parallel combination. So okay, let me break this one now. So now let's connect a voltmeter. The voltmeter is always connected in parallel combination, and it's showing 100 volt here. Now let me connect a voltmeter into series combination. So now let's say I want to measure the potential difference between these two, which is showing 100 volt. Okay, and the current is now 7 ampere. So what I'm going to do, I'm going to connect the voltmeter into a series combination. So what I'm going to do here, I'll just break up here. The circuit is disconnected. So I connected this way, positive and negative. And you see now the circuit is completed. The circuit is here, but there is no any current. The reason there is no any current, because this voltmeter has infinite resistance. So as there is infinite resistance, the current that is passing through the circuit is almost zero. So let me now do another way now. Okay, so now let me connect a voltmeter right here. Okay, so now you see now there is a current which is 5 ampere current, and now here if I connect this way, you see how much current is passing through this one, 2 ampere. Okay, so let me break this one. Okay, so now let me measure the current through this one. It's zero current, because as this voltmeter is connected, it has infinite resistance, so no current will be passing through this voltage or the voltmeter, because it has infinite resistance. There will be the current into the other component here, but there will be no current passing through this voltmeter. So wherever the voltmeter is connected, the circuit will just behaves as an open circuit. So in this case, the 50 ohm will be almost be disconnected from the circuit because we have introduced a voltmeter. So this is a wrong way of connecting. So the right way again would be connect one point here and then another point here. That's the right way of connecting. So this is it from the voltmeter and ammeter. And if you have any questions, write down your questions and do not forget to like, share and subscribe the channel.